Hey folks, happy Monday. I know it's been a while since we've been in class, so I wanted to post a video that's kind of going over the things that we've covered so far. Specifically, we're looking at how to solve square root equations and inequalities. And I'll go over both of those, both how to do it algebraically and with Desmos. So let's get started. First, I'll solve a square root equation algebraically, and then I can show how to check our work algebraically as well as using Desmos to do so. And I think that'll be really beneficial for you moving forward because anytime you solve an equation like this, feel free to use Desmos to graph it. Okay, but first let's do this algebraically. So the first thing when we're solving an equation like this, ultimately our goal is to isolate x or get it by itself. In order to do that, kind of the primary step is to isolate this radical sign, isolate the square root, because then we can undo it by squaring both sides. So the first step here, we notice we have 4 times the square root of 3x minus 2. So our first step is going to be to divide both sides of our equation by 4. Okay, that leaves us with the square root of 3x minus 2 on the left side of the equation. On the right side, 16 divided by 4, that's 4. Okay, so we've made our first step, and notice now we've isolated this this radical sign. Once you've done that, we have to eliminate it. We have to square both sides. Okay, the reason we're doing that is because squaring and square roots are opposites, and they are inverses, so they undo each other. Okay, so that leaves us with everything that was under that radical, 3x minus 2. Okay, all we've done by squaring it is take away this radical sign. We couldn't do anything else first because this whole expression was being square rooted. Okay, 4 squared is 16, so we're back to that. All right, 3x minus 2 equals 16. What we're going to do is add 2 to both sides. Okay, because now our goal is to isolate x. Now we can just treat this, now it's just a regular algebra problem. We don't have to do any other strange inverse things. Not strange, but like more complicated inverse procedures. Adding 2 to both sides gives me 3x equals 18. And our final step in isolating this unknown is to divide both sides by 3. Okay, and 18 divided by 3 is 6. So our answer is x equals 6. Now, if you're like, man, that's too much work, I just want to type 2 things in a calculator and get it done, well, you're in luck. We can definitely do that. So the way that you're going to do that is just to go to desmos.com. Just regular old Desmos, not student or anything like that. Once you go to desmos.com, once my computer loads it at any point, there we go. You'll see a bunch of different options when you go there. And all of these are useful. All of these will maybe use at different times. Sometimes you'll use the student one if you go to the student homepage. But the main thing that we're going to use this for is the graphing calculator. So click on graphing calculator. You'll notice up here, if you just type desmos.com/calculator, then that's a shortcut that'll get you straight to this graphing calculator. All right, so remember our equation. It was 4 times the square root of 3x minus 2 equals 16. So the first, let me rewrite that up top here. So remember, that's the problem we were solving. Now, we want to figure out what value of x makes these two expressions equal. So what we can do is we can take everything before the equal sign, that whole piece, 4 times the square root of 3x minus 2, and we can graph that. So I'm going to go back to Desmos. I'm going to graph 4. I'm going to type SQRT to get that radical sign. And then I'm going to type 3x minus 2. And that's it, right? Make sure that the 3, the x, the minus, and the 2 are all underneath the radical sign because that's how it was in the problem. So I can see this a graph has started to exist. I'm going to click and drag this. And in fact, I'm going to edit this a little bit so that I know I'll be able to see. Remember, my other equation is what's on the left side there, y equals 16. And so you notice that you don't see anything. That's because our axis doesn't go high enough. So I'm going to click on this and move myself out of the way. I'm just going to make sure that my y-axis goes to at least 16. I'm going to choose 20. It doesn't really matter as long as you can see it. Okay? So now to find our solution, I'm going to just scroll along, scroll along, scroll along. In fact, if I click on either one of these, this little gray dot will pop up, and I can see it's highlighting the point 616. That's the intersection point. And remember that, oh, it disappeared. Remember that the intersection point, we already know that the y is equal to 16. That's not new information to us. What is new is this value of x. So you can see that we got the same thing as we solved it algebraically. We got x equals 6, and that's how you would write your answer, x equals 6. So again, you can always use a graph to solve an equation by graphing each side of the equation as a separate function, and then looking where they intersect. All right, let's erase everything there. And then you can, if you want to start a new problem, you can just click like that. Now we can do a very similar thing with inequalities. Okay, again, you can always find the solution to an inequality by graphing. So what I'm going to do is perform the same steps. A little less complicated, underneath the radical here. That's totally fine. First up, got to isolate that radical. I'm going to divide both sides by 3. And that gives me the square root of x plus 5 is less than 2. 6 divided by 3, that's 2. All important step, eliminate that radical. Can't do anything else until we've eliminated that, so we're going to square both sides, leaving us with x plus 5 is less than 4, because 2 to the second power is 4. Final step, I'm going to get x, I'm going to subtract 5 from both sides, isolate that unknown, and so our solution set here is x is less than negative 1. Okay, and that's it. I am done. So for all values of x that are less than negative 1, I'm going to, those are all the possible solutions to this. Now, actually using a graph here is going to be a little bit more helpful because it's going to allow us to identify any other constraints that might exist on this variable. Because if you go too far into the negatives, you might start getting an undefined value, okay? So once again, I'm going to graph just each side of this equation as its own separate function. So 3 times the square root of x minus 5. I'm sorry, x plus 5. And notice again that we need to change this a little bit. You can just click and drag until you see the entire graph. All right, so there we have it, this entire graph. And we know it needs to be less than 6. So I'm going to type y equals 6. Notice that you have to type y equals. If I just type 6, it's not going to give me anything. So the second one, I got to do y equals. The first one, I can just type however I want because it's got that unknown in there, that variable. But for a horizontal line, you've got to type y equals 6. Okay. So now, once again, we're looking for the intersection point. This, and we can see it's at negative 1, 6. So we know that that's a, that negative 1 is kind of our boundary point for the answer. Now, here's what's key. We know that since our inequality was less than, right, we had a less than inequality, we want everything that's below this blue line, or everything that's to the left of the intersection point. So all of those points there along the line are part of the solution to this problem. Notice that here we can see that there's actually a lower bound. If we go past negative 5, that graph is undefined. There's nothing there. So we actually have to adjust our answer a little bit because there's a both a starting point and an ending point to the range of values here. So actually, after we've graphed this, we can see that an answer that makes a little bit more sense is 5 is less than x. Negative 5 is less than x, which is less than negative 1, because there's both a starting point and an ending point to our answer there. Okay? So if you have any questions, feel free to reach out to me via text or call today, and hopefully this enrichment work goes well for you. And I'll see you in class tomorrow after a little bit of we've had a little bit of a break. Happy to keep going. And remember that we are going to have our very first quiz on this stuff on Wednesday. So the last question on this enrichment asks if you want to go over anything in particular. That's what we'll use the starter class on Wednesday to do. All right, I will see you soon. Bye.